play around a little bit. I diffuse a fill container.
Alright, here we go. Looking at interpreting graphs. The stuff is fairly straightforward. You've got a couple of words to define. We can talk about interpolation or interpolating. The word is interpolate here. Basically there we are reading a graph along a line that we've plotted, and we are finding some value that's inside the graph. Extrapolate, or the process of extrapolation, is to look at the trend on a graph, and what we're going to do is we're going to predict some value that's not actually within our data set or not within our table of values, but we're going to basically extend the line of our graph, and we're going to use that to predict a value that's beyond our data set. So we'll take a look at how these would work, looking at first example. Very first thing that you're going to have to do is you are going to have to make a graph here. My recommendation would be that we would put altitude going up this side and temperature across the bottom. And so what you're going to do, you're going to start with the lowest temperature somewhere down here, -10. Figure out a scale so that you can easily cover from -10 up to 11.4. Remember, of course, that if we say that this first spot here is -10, we can't just say, oh, well, this one's 5. That so far seems like it would be good. But then we go, oh, and this one's 2, and this one's 5.7, and this is 11.4. Although that might look nice when we're putting it on the graph, it's not actually graphing our data accurately. So if we wanted to say that this first one is -10, second one maybe is -7, we've got -4, -1, +2, up to 5, up to 8, and up to 11. Now we haven't used up all of our graph. You can figure that part out for yourself. It's just got to be an even scale along the x-axis, and similarly an even scale along the y-axis. Now you'll notice that there's no 600. It would be somewhere in between these two. So we can already guess, okay, well, 600 is a bit closer to 750 than it is to 350. So maybe about +7 or something like that. What you're going to actually do is you're going to make your graph. You're going to figure out, okay, where does 600 show up on my graph? Trace across to wherever it intersects our line. Wherever it intersects our line, we go down, and whatever temperature that is, that's the answer. For B, same kind of a thing. And this takes us to the last question. Before you do this, pause. Do the graph. Actually do the graph. Yes, that means all. Come on, do the graph. Okay. You've paused. You've done the graph. Lovely. Now, on this graph paper, is there any way that you can tell exactly where 1050.92 meters would be? And the answer is no, of course you can't. Which means, is it possible to interpolate a precise value? No, you couldn't. Now, what you'd have to do is you would have to do the process we were working on yesterday and last week, where you're going to need to make an equation, and then we can figure out what that exact value would be. But from a graph, if we're interpolating, we cannot find an exact value for 1050.92 meters. So we've got to show you no. Now here we've given you the graph, so that makes life a little bit easy for you. Okay, right? So pause, give this a try. Right, here we go. Hopefully you have paused. Altitude at 50 seconds. So we're going to go along our x-axis. We're going to find, 50 is going to be right between 40 and 60. We trace up, theoretically with a straight line. Takes us to there. We come across to the y-axis. Oh, that's going to be 10 kilometers. Right. At what time was the plane's altitude? Approximately 11 kilometers. Well, 10, 11 would be about here. Again, with a ruler is always better. We come across something like this. We come down. It's just over 40 and not halfway to 50. So, again, we're getting approximate values here. We're going to get probably about 42, 43, something like that. Here's a question. A graphing type question. Is it appropriate to join the points with a straight line? When we look at them, they appear to be in a straight line. So yes, they would be. Now, if I had a point here, 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 there's no way I can use a straight line to graph these points. And I'm doing something like this, and that's not a straight line in any way, shape, or form. So we have to, in order to join the points with a straight line and do an interpolation, we do need to make sure that the dots that we've plotted appear to be in a straight line. Okay. Extrapolation. So we've got Anna on her present course. There she is. She's in her boat in Hecate Strait. This is just off of the coast of BC. There she goes. She's going along with this arrow. If she continues on her present course, we can extrapolate the values of latitude and longitude where she's going to land. So we use a ruler, continue in a straight line. I've drawn the little red dot for you already. It's going to be right about there. So we look and we say, okay, well, we're going to be looking at about negative 131.8 and 53.8 or 7 or something like that. Could you use extrapolation to estimate where she sailed from? Possibly. We'd need a bigger map, right? We can go over there somewhere. However, it's entirely possible she sailed from here, came around this way, and got onto this course, and then held that course until she ran her ship aground over here. So, completely, extrapolation works fine as long as we know that our data is in a straight line, and we have to make that assumption that it will continue to be in a straight line. All right. So we can show you no. Value of a computer decreases over time. The graph shows the value of a computer after it was bought. So when you buy it, it was worth 1,000. After a year, it's worth 800. After 2 years, we're worth 600. 3 years, we're worth 400. It appears to be, in case you hadn't noticed, losing $200 every year. After what approximate period of time does the computer have no value? Well, we have to assume that we can use a straight line. And if that's the case, we do this. Okay? No value, approximately 5 years. When is it worth $200? Approximately 4 years. Is it appropriate to join the points with a straight line? Yes and no. The reality is the computer never has absolutely no value. But in terms of retail value, yeah, it seems to be a good estimate. These dots that we have here are going in a straight line. Now, if this was, the value of an automobile or something like that, potentially the minivan, whip, as Damon would say, it's probably going to do something like this. And it's going to approach 0, you know, like it's close to 0 now. But it's going to curve off and never quite get there. However, for the sake of a question like this, where we see a straight line trend developing, we can usually assume, yeah, it's going to be a straight line we can extrapolate. Okay. So on a graph, you can use a line to interpolate values between known values. Okay, between, inside, in, between, yeah, okay, lovely. Interpolate is between. Okay, and then, you know, a couple things here. If you're told 25 minutes, go up to the graph, across over to here. Oh, temperature is about 3.5. Over this way, oh, temperature is about 5.5. And we come over to the graph. Oh, lovely, that worked out nicely. It's on a line all the way straight down to whatever that is, 4.5 minutes. On a graph, you can extend a line to extrapolate. And this is something I didn't mention. Usually when you extrapolate, and it's hard to do with my little mouse and pen, when you extrapolate values, as it says underneath here in brackets and italicized, use a dashed line to extend it. Basically what you're just saying there is, this is my best guess, and I'm assuming that whatever trend had started will continue. And then the process is the same. Once you have a line, you can estimate values. Okay. Alright, interpolation and extrapolation should only be used when it's reasonable to have values beyond or between